Okay, here's the introduction to the Pythagorean theorem, converse. Of course, we have the old traditional Pythagorean theorem with our right triangle, and we notice here this fine specimen of a right triangle. And if you look closely, what do we know about this? Of course, the square of the long side is equal to the sum of the square of the two smaller sides. C squared equals a squared plus b squared. But what if we expand that angle, get ourselves an obtuse triangle, you know, one of those really full kind of, that obtuse triangle looks full. Did you just finish dinner, obtuse triangle? We look closely, look at that angle, bigger than 90 degrees. And if we go down close, the long side squared is greater than the sum of the squares of the two smaller sides. So we have c squared greater than a squared plus b squared, rather than equal, which would make it a right triangle. See specimen, said specimen. Now this is obtuse, very full. And now we have, of course, the acute triangle. The itty-bitty, teeny-weeny acute triangle, who's rather cute and tiny. And he fits into that itty-bitty little triangle. Look at that little guy. Oh, the light is so bright. Let's turn away. Sorry, acute triangle. You are cute. We want to go to the acute triangle, which of course is, the acute triangle, the long side squared is less than the sum of the square of the two smaller sides in an acute triangle. Right, Graham? I'm going to point to that. Oh, yeah, isn't that cool? So we have the acute triangle. C squared is less than a squared plus b squared. So should we see that again? We have obtuse, c squared greater than a squared plus b squared. And we have right, well, we all know that's equal to a squared plus b squared. Now, Graham, you are a acute triangle. But we all know about acute triangles. Sometimes they're sharp and shrill because they have that pointy little triangle angle. But you're so calm right now. You want to say hi to everybody? See you, buddy.